Hi, it's txPrev.nTime here. 2nd of May, it's 1 degree above freezing and it's actually snowing. So what better time to talk about randomness and entropy than on a day like this. Now in the previous video I was describing basically how proof of stake works. You either keep your coins free so you can spend them, or you lock them up for a period of time, and that allows you to participate in a lottery in order to have a chance at minting one of the future blocks and thereby getting a block reward. Now this relates to proof of work in that at proof of work you have a mining rig that is churning away trying to find the next block, which is also a probabilistic event. So what you notice here is both cases you're relying on some kind of random chance in order to choose who is the lucky person to mint the next block or mine the next block and get the block reward. And the motivation is this reward, and the cost you pay to participate is either in terms of the cost of your mining equipment and the energy that it burns for proof of work, or locking your coins up for some period of time not being able to use them. In both cases what you're doing is you're making sure that the miners or minters have skin in the game. So you're relying on a sort of rational social function that people who've committed resources, time, money, or something of themselves into a system are not going to suddenly turn around and sabotage it or destroy it. So that's one mechanism whereby both of these consensus systems maintain the blockchain. The problem that has to be solved is the random selection of the next block miner or minter. And in proof of work, this is done purely through the statistical process of lots and lots of people trying random future blocks until one of them satisfies the block difficulty requirement. In proof of stake, if you go and look online, you'll find that there are lots of papers describing the basic how proof of stake works in the way that I have in the previous videos, but it's actually quite hard for a system like Peercoin to find out what's the actual mechanism whereby if you've staked some coins you get to mint a block. And I had to go and dig in the code in order to find it in the end, and what it turns out is that Peercoin, the first proof of stake system, has a difficulty too, but unlike the Nakamoto consensus or proof of work system, the difficulty varies from person to person, and it is dependent on how many coins you're staking. So the more coins that you have staked, and the longer those coins have been sitting around over time, the easier it becomes for you to be the one who is selected to mint the next block. And then the other thing that they use in order to generate randomness is to take a hash of the previous block plus your address that is holding the coins plus a timestamp. So that's how a random number is generated in Peercoin, this proof of stake system. And when I look at that, I get worried about the randomness of the system, because in proof of work the randomness is an external factor. You are providing entropy to the system by requiring these miners in the outside world, and you don't know beforehand how many of them there are, how efficient they are, how much energy they're going to spend on securing the system. Whereas a proof of stake system is totally self-contained, so you're trying to create this randomness from the internal system itself. And if you have a deterministic system such as this proof of stake Peercoin, I don't think there is a way of truly generating a random number within that system, and that to me sets off alarm bells that the system, it may be possible to game it. And I'll talk about that more in the next video. Bye for now.